As C++ projects grow, it can be really hard to manage them, particularly on the compiling and just building side. You have lots of third-party libraries that you're trying to link together and make sure that they build in an automated way so that you're not having to, manually build all these different repositories on every different machine that you pull your code down to. And perhaps you even want to be able to compile your code on different machines, like on Windows versus Mac versus Linux. You may want to be able to pull that stuff down and compile it very easily without having to commit different, a solution for Windows and a make file for Linux or whatever, right? Luckily, there are tools that make this a lot easier for us, and we should be using them. The first one is Cmake. Cmake is a build system that is going to basically generate your project files for you, and it'll handle linking and project settings and all the things you want. What's nice about this is it can compile to any platform you want. You can say, hey, I want a Visual Studio 2022 solution file, and it'll compile that. Or you can be like, oh, you know what, I want a make file actually, and it'll compile that. And it'll set it up for you, and you don't even have to submit those solution files or make files to your repository, because you can just have the users of your library use Cmake to build those things dynamically. It makes it much easier to modify project settings, because instead of having to go into the Visual Studio project settings and modify those and commit your solution, you're just changing the Cmake file, and it just works. It's amazing. In addition to Cmake, we also need a way to actually manage our dependencies. There's things called package managers that we can use. You have Conan, you have Vcpkg, there's a lot of different options. I'm going to show you Vcpkg today because that's the one I know how to use. So what we're going to do today is set up a new repository that is going to compile a solution for us with Vcpkg and Cmake that will allow us to have just a little playground to make some stuff in. So we'll probably use SDL, we'll use Glue, maybe we'll install MGUI, and we'll get all these things up and running as quickly as we can. And once it's set up, it's going to be very easy to add new dependencies, and we just regenerate our solution and so on. So I'm starting out with an empty GitHub repository. This will end up being on GitHub, obviously, so it'll be public for you guys to use if you want to reference anything I'm showing you in this video. One thing to note is the default git ignore I did change, so probably do want to take a look at that or copy it yourself. There's a lot of things that the default C++ one doesn't include, like all this random stuff and some Visual Studio things that I just don't really like committing to the repository. First step is going to be actually getting Vcpkg into this repository as a submodule. Here's the Microsoft Vcpkg GitHub repository. So we have, the code here. We can grab the URL, and then we're just going to come into our little Git folder here, and we're going to call git submodule add, and we're going to put in our Vcpkg URL we just copied, and then we'll make a folder for it called Vcpkg. Press enter. That's going to go ahead and start cloning that down and add it as a submodule. So now whenever anybody pulls our repository and initializes it, they will get Vcpkg, which we want because that's how we're managing our dependencies, and everybody needs to use that. So now we have the Vcpkg submodule. When we go in here, you can actually see what it's made of. It's actually got this ports folder that has like a gazillion things in it. This is like the entire universe in here. These are all the different packages you can get. So you actually have to keep your Vcpkg submodule updated. So you can come in here, you can pull it down like normal every now and then, just in case you want to check for new versions of libraries or libraries that may have been added to this. A lot of the very popular third-party libraries are in here, and you can even add other people's libraries to Vcpkg. You can create your own sort of ports for those. One last thing I forgot, in your Vcpkg install, you do need to run the bootstrap vcpkg.bat. That will install the executable and do some other useful things. There's another way to search for packages. You can open up, there's this handy little website, vcpkg.io. It has all the packages on here. This is always going to be up to date. So you can come in here, you can actually search for things. So you can do SDL3. Here we go, SDL3 is here. Glue is going to be here, right? So you can find all the different libraries. If it's in here, you can build it and link it with Vcpkg. Next, we need Cmake. Cmake is going to build our solution file. It's also going to be integrated with Vcpkg. So make sure to download that. Make sure it's added to your path. What you want is whenever you open PowerShell, you want to have Cmake do something. When you type Cmake, you get a usage thing here. If that's not working, it means it's not added to your path or it's not installed properly. Just make sure that works. So let's go ahead and add a little code in here. I'll make a new folder, source. Let's come into this and just make a new text document, main.cpp. We don't have Visual Studio solution built yet, so I'm just going to do it like this. I'll just edit with good old Notepad. We'll go int main, int argc, char argv for our command line arguments that we're not going to be using, and then I'll add to return 0, even though we don't actually need to put that there. So that's that. So I just realized the video was in 1080p, so I bumped the quality of the video, and I've also made a cmake list.txt. Now, the cmake list.txt is how Cmake knows how to build your project. It's where pretty much most of your configuration goes on setting things up. And let's open this up in VS Code. Now, if you don't have VS Code, I highly recommend it. It's a great text editor. You can even compile in it. So I've already done all this stuff. I'm going to just kind of walk you through everything I've done. I'm not trying to sit here and type through everything for you guys. So first, you need to say what version of Cmake that you're requiring. 3.3 works great. Maybe you want a different version, but I would go with this for now. This right here is going to set up our toolchain file for Vcpkg. What this is doing is it's allowing us to basically link it with Vcpkg. Vcpkg has its own, you can see here, this is using the Vcpkg folder that we made here that has the submodule in it. And it's linking to a vcpkg.cmake that is in its build systems folder. This allows it to scan for modules for us and build all the dependencies that we need to actually integrate this properly with Vcpkg. We're not doing anything with Vcpkg just yet, but we'll do that after we get this working. So this line right here just says what the name of your project is going to be. It's going to be the name of your solution. I'm calling it Game Dev Playground. Version is just whatever you want it to be. It's your version. And then you have your Cmake standard for what version of C++ you want. I recommend C++ 20 at least, of course. And then saying it's required, yes. We turn off C++ 20 modules. I'm not teaching you guys modules. I don't use modules. They're not super well supported until C++ 23, from what I understand. I've tried them a little bit, had a little bit of struggles with them. C++ 20 modules are really cool, but it's just out of scope for this video and out of scope for what I'm teaching in the near future. Then we need to say what is our executable going to be called. So like playground.exe is what I'm going with. You can call that whatever you want. So this will allow it to actually build your exe. And now we need to tell it where our source code is. So there's different ways to do this. I've done it the easy way, which is to use glob recurse. And there is some debate about whether glob recurse is a good idea. There's reasons why it's a bad idea. It's also very convenient. So I recommend using this, at least for now. You can Google for yourself alternatives to using glob recurse. They're not that great, to be honest. But this will basically cause your solution to scan for these files and automatically include them. And then if you add a new file of one of these types into your source directory, or you rename one, it will automatically rebuild your solution for you. So you don't have to remember to do that every time. That's the convenience of glob recurse. Now we also have the target sources. We're just basically taking these playground sources that we just built by grabbing them from glob recurse, and we're marking them as our source code for our playground project, or playground executable. Then we set up the include directories. This is saying, it's your include directories in Visual Studio. It's where it's going to be searching for include files. And then you can put preprocessor definitions here if you want. Sometimes libraries will allow you to use preprocessor definitions to configure different things, or you may want to just use preprocessor definitions for your own stuff for whatever reason. You can do that here. We also can set up libraries to link to here. So this is where we're going to be putting things that we add from our VC packages. We'll be able to say, hey, link this specific library from this package. And then if you have any libraries that you're not like using Vcpkg for, and you just have like some loose DLLs or .libs that you want to link in, you can put those here as well. You can put the directories for those, and then that'll allow it to search for those. And then here, this is setting up the compile options. So if you're on Microsoft Visual Studio, which is what I teach and what I'm using, you have the warning level, you have multi-threaded build, which there's some tricky issues trying to get this to work with precompiled headers, which I haven't taught. There's a way to do it. It's just a little more work. I'll probably teach that later. Warnings as errors, I really love having this on now. If you don't have this on, it can become a big headache when the warnings stack up. And then this ZI allows you to have edit and continue, which I think is really useful in Visual Studio, so I recommend having that option on as well. And if you're not on Visual Studio, here's some just basic compile options. I always compile in Visual Studio, so you may want to add some different things here. I zoomed in a little bit. Hopefully that helps. So there's just a few other things at the bottom here. There's some just handy things, like you can set up your startup project, which right now we only have one project, so it doesn't matter. But if you have multiple projects, that can be kind of nice. This is setting up filters. So by default, it'll kind of just list all your source code in a big pile. This allows it to create sort of a filter tree for you. And then enabling the folders works hand in hand with that, if I remember correctly. So we have our Cmake lists now, and we can actually use this to generate our project. At this point, we can run Cmake directly from the command line and generate any kind of project we want. What I like to do is create a batch file, at least for Windows, to make this really easy to just build sort of a default configuration. In this case, if I open this up, you'll see what I set it up to do is build a Visual Studio 2022 solution. And it's just going to set up a command and run it very simply. So let's run this and see what happens. As you'll see, it's running our Cmake command, and Cmake is deciding to build our stuff with certain SDK versions and compiler versions, blah, blah, blah. And once that's done, what it's going to do is output this build folder here. Inside this build folder is all of the generated solutions and project files, all that stuff that you would normally have to make yourself. And it has all of the configuration that we set up in that Cmake file. Now, what we don't want to do is commit this to the repository. So we should make sure, if I open up PowerShell, that this is not, it needs to be excluded in our git ignore, because we don't want to accidentally submit this thing. It's supposed to be something you always generate on your local machine and you never check in. So we have this build folder. It is untracked, but it's able to be added to the repository. We don't want it to be in the untracked list here. What we want to do is add it to our git ignore. So I'm going to open up git ignore again and just add at the bottom that folder. So it's called build, and save that. And then now we should be good to go. Now, if I open PowerShell again and I go git status, we have excluded build. That's what we want. Now, whenever we make some kind of change to the configuration, it should automatically rebuild for us. There's a project here called ZeroCheck. It's a very strange name for a project, but this is a Cmake specific project that always gets added to your solution. This is a prerequisite that runs for your other projects. So we have like this Playground VCX project. That ZeroCheck will run first, and it's actually going to check and see if we should regenerate the solution. So if our glob recurse files that we set up, if those change, then it will regenerate our solution. Or if the Cmake file itself, the Cmake list.txt, if that changes for whatever reason, it'll regenerate our solution. So you'll see now we have Playground here, we have source files, and we have main.cpp. This is the main.cpp we made before, and our solution is here. And we can compile and run, and it'll just return 0, probably, just do nothing. Yeah, and what we want to do now is actually build something, right? So we want to add some dependencies. We'll start with SDL, so we can get a window up and running, and we'll also use glue for our OpenGL extension handling. Now, there's 2 more files we need to add to set up our project for Vcpkg integration. The first one is the Vcpkg configuration.json file. I'll show you what that looks like here. So this is a JSON file that is going to basically just kind of link us to the Vcpkg GitHub as our main registry, because we pulled that down, we set that as our submodule, we're using that as our toolchain file. That has, that big ports directory with all those ports, but there's technically other places you can get things from. So that's our default registry. It's a Git repository. It's obviously the URL of the GitHub repository. There's also this baseline. This is the commit hash. So this is not up to date. I actually need to change it. So if we go to Microsoft VCPkg, basically, this is saying what version of the Vcpkg repository are we using in this project that we've made. We just go to the commits here. You can pick one. I just pulled within 7 hours, so I'm going to go to this commit here. And the commit hash is here at the top, so it's in the URL. I can just grab that, and I can put that in here to replace this old one. There we go. So now our baseline is up to date. Anytime you want to, update, because say you want a new version of a port, or you have just a new library that got added that you want to include, just make sure you also update your baseline here. This registry, this artifact registry here, it's like some additional Vcpkg tool things. I honestly don't remember what this is for. I'm not even sure if it's required, but I recommend including that because that's what I have been using. So now there's one more thing we need to add. The last file we need is the vcpkg.json file. So this is just another JSON file. This one's going to describe the dependencies that we actually want to use. So I'll open this and show you what I wrote. It's very simple. You name your project, Game Dev Playground again. So this is just like our sort of Vcpkg solution here. This is an illegal name here. This needs to be lowercase Game Dev Playground with a hyphen. This is what it wants. You can give it whatever version you want. This is yours. And then we say what dependencies we want this project to pull down from the Vcpkg repository and build. So to figure out what we should put here, we're going to open up our vcpkg.io here, and we're going to browse packages and just look for the name. So SDL3, probably just called SDL3, yep. So we'll put a new string here, SDL3. And then I assume glue is also just glue, but let's look. So we'll come back here, glue, yeah, just glue. And we can also do mgui. I'll add mgui later. And finally, we need to actually alter our Cmake lists. So we have set up the dependencies in Vcpkg. We need to actually link these into our project. So what we can do is at the top, we'll maybe add a section here for add dependencies. And the way we write this is we type find package and then the name of our package, so SDL3. And then usually you want to put config and then required, saying this is a required package. Config is the newer way. It searches for packages. If for some reason it doesn't work with your particular package, you can try removing config and see if that works. So we have SDL3 and then find package. We'll say glue config required. And this is going to find the package and it's going to sort of prepare it, but it's not going to actually link it with your particular project. We have to link the libraries that those projects provide, and we'll do that down here in the target link libraries. For this next part, the easiest way to figure out what we should put here is to actually open up the Vcpkg repository, the Microsoft one, and we want to actually search for our specific package. So we're using the SDL3 dependency. There's usually going to be a usage file here that tells you how you're supposed to hook this up. It tells us not only the target link libraries here that we're about to set up, but it also tells us how to do the find package with the config being set in this case. So we're going to grab this. It's all caps SDL3, SDL3. And then it looks like I think I actually got this part wrong. It's all caps for the find package here. So let's do what it says. I believe glue is probably also the same, so I'm going to go ahead and start doing that. Glue, we'll go ahead and check though to be safe. So we'll go back here. We'll search for the glue usage, and I'm gonna bet, yeah. So caps again, glue. So I did that up here, and now this is actually going to now link our two dependencies with our project. So I shouldn't have a comma here. We should go ahead and save this now. So now when we run generate solution, it's going to now run vcpkg install, and it's going to basically just fetch all of the dependencies that we added. So it'll grab SDL3 and it'll grab glue and install those. So I'll wait for these to finish. Now this might take a while, and before I forget, I want to actually mention there is one small issue, you could say, with the way I set this up that I forgot to mention. So this comment kind of explains it here, but we are manually setting the Cmake toolchain file to Vcpkg in our Cmake lists, which is basically just binding it to this particular install of Vcpkg. And if another user wanted to install our library and use their own toolchain to build this, they wouldn't be able to. So what you're really supposed to do is make a Cmake presets.json file that handles this kind of a thing, and then users can kind of override that with their own user profiles. I'll put a link in the description to the documentation for Cmake and Vcpkg. That should help make that stuff more clear. I was just being a little lazy here. Okay, and this finished, and we can see here that it did give us SDL3 and glue. So now when we go to our little game dev playground here and launch it, we should have access magically to all of those includes, and the libraries are already linked. So we're just straight up able to now use SDL3. So I'm going to go in here and test that out. So I did a little coding off screen. I included SDL3, SDL.h, glue.h, created this scrappy little game window here. Again, this will all be on GitHub, not that you actually want this. And then we just, pull for the quit event and then quit when we click the button. And there we go, it works. We've got glue, we got an OpenGL context, we've got a game window, everything's working. And it was relatively painless to set up with Vcpkg. Now, I have heard that Conan is a lot easier to use than Vcpkg. That may or may not be true. If you don't like Vcpkg, maybe give Conan a try. I can't give you a tutorial on that because I don't know how to use it, and I frankly don't want to learn it right now. So yeah, in future videos, we might use this little project to play around with different things that I'd like to teach, and then we could just end the video here. So thanks for watching, guys.